Good day and welcome. Today I'm going to talk to you about an exciting project that I've been working on as an awardee of the American Academy of Family Physician Foundation's Emerging Leader Institute. The project is entitled Technology-Driven Diabetes Management. The aim of this project is to serve as a demonstration of innovation that can be integrated into family medicine. For those of you who are unaware of the Emerging Leader Institute, I'll provide you with a few details. The Emerging Leader Institute was created by the AAFP Foundation as a vehicle to inspire and empower family medicine residents and medical students to enhance their leadership skills and create a pipeline of leaders for the future. Our class, which you can see on this picture, was the inaugural class. We had the opportunity to spend several days together in Kansas City. We learned from an outstanding group of mentors. We're inspired by the collective energy of everyone present. It was at this experience that I came up with the idea for a project to enhance diabetes care through the use of technology. As a resident physician, I regularly see diabetic patients in the clinic. So, let me begin by sharing with you a story about a patient encounter that made me realize just how important it is that we change the way we practice diabetes care. In order to protect the privacy of my patient, let's call her Ms. Smith. Ms. Smith is a type 2 diabetic patient who for the past 2.5 years has reliably come to all of her visits every 3 months. She does her best with her diet. She likes to do water aerobics. However, she's routinely overwhelmed and at times confused by the amount of medications that she needs to take for her diabetes care. This is completely understandable. We ask Ms. Smith to take oral medications for blood sugar, for blood pressure, for cholesterol. We ask her to check her blood sugar multiple times a day and give herself insulin injections throughout the day. So, my story starts about a year ago when I wanted to add a medication to help Ms. Smith improve her blood sugars. The medication, for those clinicians in the room, is called Januvia. Fortunately, or so I thought, this medication comes as a combination pill with another medication that she already takes, which is metformin. Seemed like an ideal solution as the patient would be able to get the benefits without having to take yet another pill. We discussed the risks, the benefits, and we decided it was a good course of action. We scheduled a follow-up in 3 months. When I saw her back at 3 months, Ms. Smith stated that she stopped taking the pill because she thought it was giving her side effects. She figured that she would just tell me when we saw each other at our visit. When I asked how long she took it, she said, about 2 weeks. So for those of you doing the math, that means she was not taking it for the past 2.5 months. But the real problem stems from the fact that it was a combination pill. So not only was she not taking the new medication, but she was not getting the metformin component that she had previously been on. This led to her having even less medication for the past 10 weeks than she was taking before her last appointment. Now, I certainly do not blame Ms. Smith. It makes sense that if a medication that was just started and was not working, it'd be okay to stop it. Of course I wish that she would have called me and that we could have at least resumed the metformin component. But most importantly, it got me thinking there has to be a better way for us to manage patients with chronic conditions such as diabetes. And we need to find a way to use technology in a meaningful way to assist us. So we'll come back to Ms. Smith later. But let's step back and look at the challenges of diabetes management in the United States. Diabetes mellitus is a widespread disease. It affects 387 million individuals worldwide and is projected to exceed 500 million by 2035. Despite spending over $175 million annually in direct medical costs, there's been an overall lack of success with the disease management. We possess a vast array of medications, diagnostic tools, we have guidelines for managing this disease, yet we're losing the battle. How is it that we're not making better progress in this fight? The answer lies, at least in part, in the phenomenon of clinical inertia. And just like the inertia that Isaac Newton described, an object in motion, like this ball, tends to stay in motion, and an object at rest, like these other balls, tend to stay at rest unless acted on by an unbalanced force. The same thing happens in medicine. We continue to see the same patients with the same problems, make the same changes that have not worked. We repeat the cycle every 3 months and hope for a better result. Unfortunately, history has proven that our current methods are not working, and they are not likely to work unless we find innovative ways to take better care of our patients. What can we do to find better ways of providing care? Let's take a moment and think about this problem. If you're a clinician, I want you to think about your patients. If not, I want you to think about a friend or a family member with diabetes. Start by relaxing and imagine a world where the only goal is to make this diabetic patient's disease better. Strike from your mind the concept of fee-for-service, our current model where the patient sees a physician and the physician bills the patient. What would you do differently? What would an ideal interaction look like? How do you want to know about this patient? How often would you want to communicate? When I've asked my colleagues these questions, many simply have never thought about these questions and could not come up with any quick answers. In many ways, this goes back to a discussion about inertia. We're in a world where the physicians have been trained how to manage patients from visit to visit, but we have less skills and systems in place to specifically manage outcomes. As you can probably tell by now, I strongly believe that we can incorporate innovation and technology to help us overcome these challenges. Furthermore, this exercise in imagination might not be as far off as we think. Let's go to 2015 when Congress passed the Medicare Access and Chip Reauthorization Act, also known as MACRA. Now this bill received a great deal of press and attention as the Doc Fix law, because it fixed a loophole in physician compensation. However, the lesser known but longer lasting impact of this law is the federal mandate to incorporate value-based component into physician reimbursement. The law symbolizes the changing winds of the expectations of insurance companies. In the near future, it will be more than an exercise in imagination. It's time that we design creative solutions and think outside the box to solve this problem of clinical inertia. Let me pause here. So far, we've already talked about the challenges with Ms. Smith, the lack of success, financial strain with our current methods. We've discussed the impending mandate to come up with new solutions. So where do we start? For the purposes of my project, I decided to tackle 2 interrelated problems. The first is a difficulty with efficiently acquiring relevant information about our patients from these electronic health records. The second is the lack of communication with our patients in between the visits. As I stated, despite the multi-billion-dollar investment in electronic health records, the ability to view patients' data in a meaningful way remains elusive for physicians. This picture illustrates what chart abstraction often looks like. A clinician reviewing the records of a diabetic patient, they'll likely turn on their computer and start looking for key pieces of data. This will include going to the medication table, looking at the patient's glucose control medications, their ACE inhibitors, other blood pressure medications, as well as statins or cholesterol medicines. After looking at the medications, it's time to identify any medications that are not prescribed. Cross-reference this with allergy section to identify a reason for not being on the medicines. The clinician will then move to the lab section, sort or filter for the latest hemoglobin A1C, the last lipid panel, further check for urine microalbumin, and for each lab the data is noted and the clinician will need to analyze that to see if there are any due for a repeat check at the upcoming visit. Next, it's off time to check for immunizations, podiatry exams, eye exams, etc. Each of these is a time-consuming step performed for every patient with diabetes. And that's just one medical condition, and that the patient may want to discuss. Each clinician has his or her own way of jotting down these disparate findings on paper or other duplicative electronic source. Despite all the time invested, the clinician has not actually done anything more than gather data. No medical decisions have yet been made. No improvement in the patient's care plan have been executed. On top of that, every time this information is transcribed, there's a chance for clerical error. As part of my project, I want to investigate if this process can be streamlined and give that time back to the physicians. Let that time be used for decisions that require a medical degree and benefit the patient. In addition to the difficulty acquiring meaningful data in a quick fashion, communicating with the patient between visits is grossly lacking. In common practice, we as physicians see our diabetic patients approximately every 3 months. Nothing stops us from seeing them more or less frequently, but we often have no way of knowing who needs to be seen more frequently and who needs to be seen less frequently. Unfortunately, our current methods of communicating with the patients is their patient's ability to log their blood sugar. We expect them to check their blood sugar often 2 to 3 times a day. We expect them to write down these values in a log. We expect them to bring the log with them to their visits. Each of these steps is a potential breakdown in communication. And in the best case scenario, we're presented with a stack of paper at our already short office visit and have to try to make sense of this information while also doing other tasks such as performing a physical exam, refilling medicines. And other than the cumbersome and expensive methods such as making random phone calls, we have no way of knowing if a patient is doing well between visits. We do our best to give them parameters for when to call us, but at times our overwhelmed patients are simply unable to recognize the same problems that we would. So let's go back to our example with Ms. Smith. It's usually okay to see her every 3 months, but in the instance where she stopped her medicines, I needed to see her sooner. So, hopefully by this point I've convinced you that diabetes is a major problem. Our current methods of dealing with it are simply inadequate. This brings me to my specific project using technology to drive diabetes management. In the short 9 months since conceiving this idea with the Emerging Leader Institute, I'm very pleased to present my progress to date. And due to the accelerated timeline, I chose to design a proof of concept for how I could use technology to innovate how I care for my diabetic patients. It's worth noting that all of the work I had, and I will show you, was done with a very busy schedule as a resident physician with no budget and limited elective time to put towards this project. I point this out not for a pat on the back, but to demonstrate that focused, innovative ideas do not need or require years of planning or millions of dollars to investigate. So let's take a look at a simple solution to the data collection problem that we discussed. I believe that sometimes the simplest solutions are the best ones. I wanted to quickly find a way to see how my patients were being managed with regards to the current practice guidelines. For example, did my uncontrolled diabetic patient have a hemoglobin A1C within the past 3 months? Did they have their lipid panel checked in the last year? Regarding medications, are they on aspirin, statins, an ACE inhibitor, or an angiotensin blocker? If they're not, is it because they have an allergy or intolerance to that medicine? So in order to streamline the data that I need to see as a clinician, I worked with our IT professionals to have data extracted from the electronic health record. They were only able to provide me with one file that listed the diabetic patients and their demographic information, and another file was given the medications, and another the labs, and finally the allergies. Through some relatively simple processing of the files, though, I presented them in a single report. This report was immediately more useful than what I had previously been working with, but it still required me to look through it line by line and find discrepancies. So with yet again very basic commands, I added color-coded logic to identify areas that needed to be addressed at the patient visit. And whereas this was never intended to substitute for my clinical judgment, it certainly directs me to the areas that require my attention. I can see huge implications for a simple idea such as this that allows us to perform automated data abstraction that helps us manage our patients by the guidelines. This gives a possible technological solution for assisting physicians in rapidly analyzing large amounts of data on a single sheet. But let's turn to the arguably larger problem, and that's of communication with our patient. In the quest to gather better diabetic data between visits, I analyzed a number of technology solutions. In the world of diabetes management, there are many options. One option is to have an application on a smartphone or a computer that allows the patient to type in their blood glucose values. After they check it with a meter, they can have these logged. This is certainly a step above the paper log, as the software can perform calculations and look for trends in the data. And I found this option to be intriguing, but many of my patients do not have phones or computers and may find this to be cumbersome or technologically challenging. The next thing that I researched was the use of blood glucose meters that could transmit data via the internet. These devices have great promise, as the patients can transmit all of their blood glucose readings to the clinician's office via cloud-based solutions. They work very well for many of my patients. However, many of my patients don't have computers or phones that are connected to the internet. Many of my patients do not have the ability to sync up a meter with an internet accessible device. So in my research, I discovered the concept of a cellular-based blood glucose meter. These meters work similarly to the internet-enabled meters, but they have a built-in cell phone that can transmit the data to a cloud-based portal. The patients do not require any additional internet access or computers to hook up to. Additionally, as long as they are in the range of a cell phone tower, their blood sugar readings are instantly sent to the clinician portal for potential review. So I want to pause here and give a huge thanks to the Telcare company who makes these meters. As a resident with my aforementioned $0 budget, I asked the company if they'd be willing to donate a few meters for my project. They kindly provided me with 10 meters to see if this technology can help address the communication problem that we face. Now, my patients quickly acclimated to these new meters, and they are helping me to change the way that I provide diabetes care. Now, let's go back to the discussion of diabetes care in Ms. Smith. With the use of cellular meters, I'm able to see each and every time Ms. Smith checks her blood sugar. I know what time of the day it was, and whether it was before a meal or after a meal. Now, this has made a huge difference in how I can interact with Ms. Smith. I can honestly say that I have a better idea of how she's doing with her diabetes management. Now, by this point, you're probably thinking that this is all well and good, but no one can sit around and look at whole panels of patients' blood sugars all the time. And you would be absolutely correct. This is precisely where technology comes to the rescue. This project has reinforced that we need to rely on technology to do what we cannot. One of those things is looking through mounds of data and alerting us to the important pieces. And much like a tornado warning, a blood sugar alert has to have the same properties. It has to be timely, and it has to be actionable. With the computers doing the real-time glucose monitor, I only need to wait until an event happens that needs attention. The project has proven to me both the benefits of alerts as well as the pitfalls of inappropriate or excessive alerts. Alert fatigue is a real phenomenon, and it could derail a project like this very easily. If we had a tornado watch every day for a month, the effect would be lost. So is the case for blood sugar alerts. So as I continue this project, I'll be working to personalize the alerts that I'm getting from my patients. I'm working to design simple thresholds so that when an alert is sent, it's meaningful to both me and to the patient. And though I'm still quite early in the process of implementing this technology, I'm already finding ways to increase the meaningfulness of each and every alert. I'd like to now show you an example of a patient alert. This particular patient, fortunately, is not Ms. Smith. They had a very high blood sugar reading. I need to know about this. The patient needs to know about this and what to do about this. What you can see on this report is exactly what the patient sees on his or her meter. The message is clear what to do. At the same time the patient receives this, I'll receive an email with the same alert. This solution opens up the communication channels between the patients and I. I will allow the computers to do the heavy lifting, sorting through these, but alert me to the significant events. So lastly, let's return to Ms. Smith. First, you'll be very happy to know that I'm finally making progress with her blood sugars. I saw her recently. I made a small change to her insulin regimen. Over the course of the next 2 weeks, I watched for any changes, and whereas this change was subtle, it's noticeable. She has not had a single blood sugar reading over 200 since the change. I will not need to wait 3 months to see if the impact of my intervention worked. In fact, we will likely talk on the phone in the near future and continue varying the interventions. So we have covered so much in a short period of time. I hope that I've inspired you to see the possibilities of innovation and creativity. Going forward, I hope that I inspire others to come up with answers to our imaginary scenario of what we might do differently if all of our focus was on improving patient care. I can see great potential in both the passive aspect of automated chart abstraction and the active aspect of using technology solutions to monitor our patients much more frequently. I envision a world where the technology alerts us to the most needy patients. And it would not be hard to imagine these same concepts being applied to other chronic diseases. Just imagine if our patient had heart failure. We could do a similar list. We'd be able to quickly analyze their medications, their last echocardiogram, and when they last saw the cardiologist. With the use of fitness monitors and Wi-Fi scales, we could easily be alerted to abrupt changes in their weight or their activity level. The possibilities are endless. I, for one, am extremely excited about what the future holds, and I do hope that each and every one of you is also excited about the power of incorporating technology into patient care. I cannot thank the folks at the AAFP Foundation enough for inspiring me and motivating me to work on this project. So thank you so much for listening. I also want to take a moment and thank a few individuals who helped me along the way. I want to thank all of the staff at the AAFP Foundation, Dr. Conrad Flick, my advisor, Dr. Julie Kirk, our diabetes educator, and all of the faculty at Wake Forest Baptist Family Medicine who supported me. And last but not least, I want to thank the folks at TelCare for donating the meters. All the best, and have a good day.